Energy evaluation. The film was prepared by a team from the complex of construction schools No. 1 in Poznan as part of the Recover IND project. Energy assessment of a building and building information modeling. How to determine a building's carbon footprint. Dedicated tools are available to assess the environmental impact of buildings. One of them is the Life Cycle Assessment, LCA, analysis, which is based on the assessment of the entire life cycle of a building or its main elements. According to the PNN 15978-2012 standard, this analysis is based on the division of the process of a given investment into its individual stages, phases. Product phase, A1, A3, includes carbon dioxide emissions associated with the extraction of raw materials from the ground, their transport to the place where they will be produced, and primary energy used from the transformation of raw materials into construction products that will be used to build the building. Construction phase, A4 and A5, includes the processes from the gates of the building products factory to the practical completion of the construction work. It includes all transportation of materials and products, including intermediate storage and distribution, as well as the processes involved in constructing and erecting the facility. Use phase, B1, B7, covers the period from the completion of construction works to the demolition of the building. It covers a wide range of emission sources associated with the operation of the building, including heating, cooling, electricity consumption, water supply and maintenance, including cleaning, repair and replacement of building services. End-of-life phase, C1, C4, starts when a building is taken out of use and will not be used in the future. It includes demolition and any impact caused by transport during demolition. External impacts, D. Demolition should be seen as a process that provides a source of materials, products, components that can be reused, recycled or recovered. The analysis of the individual phases allows to implement solutions and to counteract the negative impact on the environment. The contribution of each phase to the amount of carbon produced for the construction and use of the building depends on the materials used in it and the design solutions adopted. To begin the energy assessment of a building, it is first necessary to create an ArchiCAD model of the object we want to examine, a virtual twin. With the Zone tool, create zones in each heated or conditioned space in the building. Use the fit to surrounding partitions by selecting the use of the zone construction inner edge exclusion. Then open the View tab, expand elements in 3D view and select Filter and Section Elements in 3D. Select the checkbox for zones to make the zones visible in the 3D view. For the energy estimate, the previously prepared zones should be grouped into thermal blocks. Open the Project tab, select Energy Evaluation, you will return to this frequently, and open the Energy Model Overview. Create a new thermal block. You can change the name and ID. You will be combining those zones that have the same utility function into one thermal block. Use the Add Zones option, then add all zones. Now set up your usage profiles. Select Options, then Element Attributes, and then Usage Profiles. A usage profile must be determined for each thermal block. You can choose from a list or create your own. The heat output of people, the hot water demand and the moisture load must be determined. In the daily schedule, you can select different times of use for different days of the week. Next, select the average air temperature and then calculate how many square meters one person occupies in the entire property. Return to Energy Evaluation and select Building Installations. Configure building installation settings for each thermal block, type of heating, ventilation and air conditioning, if used. You can edit the parameters of the heating, ventilation and air conditioning systems and assign them to the thermal block. Now select environmental parameters in the energy estimation. Open the Project Greater Than Energy Estimation Greater Than Environmental Parameters dialog box. Set the location of the object. Change the name, give the exact address and the latitude and longitude. You can use a map for the location. Click on the globe icon, find and mark the building on the map. Enter the altitude above sea level and the orientation of the building in relation to the directions of the world. Select the soil type underneath the building. Also choose the type of surface surrounding the building. Do not change the light reflection from the ground. When you select the surroundings, the light reflection will change by itself. Select the exposure to wind. You need to know which way the building is facing. See if it is sheltered, for example by trees or another building, partly sheltered or not sheltered. For each orientation, a point will be inserted on the graph to indicate the wind exposure. The further away the point, the higher the exposure factor, and the points are connected by a red line. We then choose to shade the building from different sides by plants. Set climate data, select the connection to the Strusoft server. Check if the climate type is selected correctly. Now check that the U factor is correct. If partitions in the project have been correctly configured, then it will be correct. If something has to be corrected in the U factor, click the button with a dot in the column of U factor and enter the value. Check the tab concerning walls and floors as well as windows and doors. Finally, update the zones and then start the energy simulation by clicking on the Start Energy Evaluation. An energy audit report will be prepared. You can select which elements you want to include in it. You can save the file in PDF format. Thank you for your attention.